I can't remember doing that.
Okay, and you have, unfortunately you have to do it for every one. You can't just guess, because this one actually is 930, not 960. So the next one would be 90 times 7 plus 120 times 0, and that gives you 630. So, but the problem is that's not the maximum one. So the idea in this problem is that like all of these are possible points, but only one of them gives you a maximum income.
Okay.
So let me see if I can find one here real quick for us to do. Okay. Okay. Yeah, let me. Okay, so do you have your Desmos like available? Can you pull that up?
Go grab it.
Okay.
I have it.
Okay, so I want you to graph both of these on your whatever you've got there, and I'm going to help here too. All right, do you have those kind of graphed up here?
Yes.
And you don't have to do the last two, but what I want to know is where that intersection point is. If you can click on it, hopefully it's nice.
Yes. I found it.
Can you give it to me? Give me that number.
Parentheses 1.65, no, 1.615, comma 3.231.
Okay, so unfortunately this didn't give us a nice number. Let's just assume for a moment that it's actually a 2, 2.
Okay.
Roughly, or 2, 3. Let's go with that. Okay. What is this edge point up here? This I'll call it A. What is the value of A there? Can you see that on your screen?
Yes. The value of A is 30.
That's the one down here at the right, B. B is definitely 30. What is A?
Oh, wait. 07.
0. Nope. That's up here. So do you see where they're both overlapping?
Overlapping.
Yeah,
but it doesn't give me a point.
Did you graph the? You should be able to click on the axis and that line. Kind of where my mouse is, you should be able to click on there and get a number.
Nope.
Okay, it's 0, 5. All right. So now there are three what are called 3 corner points. There's actually another corner point at 0, 0, but you never use that one. And so we're gonna make a table with those points. So we'll go 3, 0, 0, 5, and then the one I made up 2, 3. And this one, they want you to maximize the following: 39x plus 26y. So you have to put 3 and 0 in for x and y and come up with a number. So can you do that for me?
Put X for number.
Yeah, you're putting 3 in for x and then 0 in for x. 0 in for x, 5 in for y.
Okay.
And you're trying to figure out which one gives you the biggest value.
Y.
So what I'm asking you to do is 39 times 3 plus 26 times 0 and give me that number.
Oh, okay.
And if you need to, you can use the Desmos calculator, handheld calculator, that's fine. Don't want you to do it by hand. That would take too long.
$143.
Okay. Wait, for this first one?
Oh, for the first one, okay, let's do it all together. 117.
Okay. And how about for the last one? Maybe that was 143.
Yeah, it was
Okay. So which one's the largest?
143.
So at this point here.
Yeah.
Okay. Let's try another one here. I think this one has a nicer solution. Okay. We're going to do this one without Desmos though. I want you to see how this is done. Not because I want to do it by hand, but because you can sort of shortcut. Oh, darn, this one doesn't have a nice. Let me change this to, boy, let me change this to 40. And that'll work a little nicer. Okay. So that first equation, 4x plus 5y less than or equal to 40. You've probably seen this before where like when you make x equal to 0, do you see how the 4 times x goes away?
Yes.
And it just becomes 5y equals 40. Well, what's the y value there? 5 times what number gets you to 40? Or divide both sides by 5.
8.
Yes. So y is 8. So we put a dot there on 8. Then you do the same thing. You let y equal 0. And then that 5y goes to 0. So it's just 4x equals 40. So what is the x value? 4 times what number gets you to 40? Right, you're dividing both sides by 4. What does x equal?
10.
10. Perfect. Okay. And so we connect these two lines or connect these two dots with a line. Great. All right. Now we can do the same thing now for the second equation. So I want you to try that. I want you to set x equal to 0 and then figure out what y is, and then set y equal to 0 and figure out what x is.
Is I think the x is 4 and the y is 5.
When x is 0, y is 4. That's for sure.
Okay.
But when y is 0, that 5y goes to 0. So it's just x equals 20. And I know you don't have the grid paper up, but do you see how these hit?
Yes.
It sort of looks like that. Now, I'm just going to, for the moment, assume that that is the solution. That is 6, 4. Okay. Now, the overlap is always at these other lower vertices. So this one's is at 0, 4. That can't be, sorry, this is 6, 3, not 6, 4. And then 10, 0. So now what I want you to do is make a table here. I want you to put your ordered pairs in a table here. You've got 0, 4, 6, 3, and 10, 0. And I want you to calculate this 8x plus 2y for each of them.
Is it 6, 3?
Well, give me the numerical values for each of them.
Oh,
What is the first one? 8 times 0 plus 2 times 4. What is that?
$64.
No, 8 times 0. 8 times 0 is 0. And 2
Mhm.
times 4 is
4 is 8.
just 8. That's right. Now, do it for the next one, please.
Okay. $150.
So 8 times 6 plus 2 times 3. You got 8 times 6 is 48. And 2 times 3 is 6. I'm going to go with 54 on that. So are you using a calculator? Are you trying to do it by hand? Give me some more
I'm
information.
using a calculator.
Okay, I think maybe just there's some errors entering that in. The last one though is 8 times 10 plus 2 times 0.
8 times 10, 80 plus 2. 82.
It is 80 because 2 times 0 is 0.
Oh, so the highest is 80.
Yeah, and usually it's on the like you may have seen a lot of problems where this wherever they intersect is the maximum, but you have to be careful. It really depends on the function that you're maximizing. Okay, let's move to a new topic here. Let's talk about polynomials. Okay, so we're restarting the lesson here, or you're restarting a chapter or unit in your book. So what you're used to maybe is something like this, like 5x to the fourth minus 3x squared plus 2x minus 1. And I could ask you for what are the coefficients of the polynomial? So the coefficients are the numbers in front of letters. So what are the numbers in front of the letters?
X.
No, the number.
Oh, 5, -3, and 2.
Very good. This one's usually excluded. In the way that now your course is doing it a little bit more different. They're like, let's try to confuse them. They're going to like go something like this, like minus 2.7c plus 5.1b minus 3a. So what are the coefficients this time?
-2.7, 5.1, and 3.
-3. It always takes on the operator.
Okay.
Okay. So the next types of questions they are going to ask you here is they ask you, well, what is a polynomial, or which one is a polynomial from this? It's actually easier to tell you what is not a polynomial. So these are the things you're looking out for not. You're looking for negative exponents. You're looking for division by a variable. Okay. You're looking for fractional exponents. And there may be others, but that's all I can think of at the moment. So let me give you some examples here of things that are not polynomials. So let's say it's y equals x to the -2 power. Why is that not a polynomial?
There's no numbers next to the letters.
No, okay, so I'll put one there, 3x to the -2. Your answer should be one of these three: negative exponent, division by a variable, or fractional exponent.
Oh, it's negative exponents.
Yes, okay, but it's really negative exponents on the variable. Okay, because this is not, but the following is, let's say it's a 5 to the minus 2 times x cubed. This is a polynomial. So you don't care if there's a negative exponent on a number, you only care if it's on the variable.
Okay.
Okay, so let's look at the next one here, division by a variable. So let's say y equals 1 over x plus 3. This is not a polynomial because you're dividing by a variable. Is that okay?
Yep.
All right. So I wish we had another problem here, but we don't. So we'll do that next. We'll see if you get, when you do another one of these, we're in 16.1, maybe you'll have it'll be clear which ones are right. So now we talk about two terms of the polynomial. So let's say it's a minus 5x squared plus 3/4 x minus 2y. Okay, there are 1, 2, 3 terms. So terms are separated by a plus or a minus. The minus, though, goes with the term.
Okay.
So the terms of the polynomial here would be minus 5x squared, comma, 3/4 x, comma, minus 2y.
Okay.
Now your book does, your class strategist does some weird stuff here. They do, and you can even have constant terms. Let's look at one of those. Minus 5x squared minus 45x plus 3. What would be the 3 terms of this polynomial?
Negative, negative, positive.
The terms include the whole thing. You have to actually give the whole number and letter.
Okay, so negative 5x
Squared.
squared.
Yep. What's the
Okay.
next one?
Negative 45x.
Okay. What's the next
and
one?
Positive 3.
Okay. So here, this will probably be our last problem. Then I'll have your brother jump on the lesson today. What are the terms of this one?
6x square.
Okay.
7y square. Negative 4x.
Negative 4x and
negative 45.
good. If it were me, I would go and do that lesson one more time. Probably will take you under a minute and you can get full credit on it for 16.1. All right, so if your brother's around, have him jump on, or if he's jumping on another computer, let him know that that we're ready.
Okay, he's right here.
Okay.
What? No, I'm not. Did I spell?
Hey, Noah, are you there?
Yep.
All right, are you ready to do some math?
Not really.
Okay, that's understandable. Have you been following your brother or your sister's lessons over this format?
Nope.
Okay, so this is your first time seeing the screen, is that right?
Yes.
Okay, so I'm sharing my screen now. I send this to you at the end as a PDF, and then there's a link to the screen recording so you can look at it later. Your dad asked me to go through some proportion stuff with you, so I've just got to get back to where I can see your class. Do you remember what you were working on today in class?
I think all I know that I've been working on ratios. I think I'm working on like unit ratios or something like that.
Okay, let me get where I can pull that up. Just give me a moment here to get back to that. All right, so you are in math 6. Does that sound right?
Yeah.
Cool. Why can't I see you? All right, I'm just gonna mute myself for a moment. I'll be right back as soon as I can figure out where I can find your class. Just bear with me here. Thank you.
Yeah.
All right, so no, I'm having a trouble actually loading up your class. Do you have any way to pull it up on your screen?
Yes. Let me grab my computer.
Okay. This may not work here. Let me show you what I'm seeing. Well, if you're, let me know when you get back.
I'm back.
I may have found it here. Okay. Yeah, I did find it. All right, it's we'll be settled here shortly. Okay, week 9 ratio part to whole. Is that something you've been working on?
Yeah, just calculating unit rates.
It looks like you got a Word, like your instructor gives you a Word document to print out. Does that sound about right?
Workbook.
Well, I'm seeing some problems here. Let me grab one. Okay, let me snip this in. Okay, so if you're seeing my screen, is this something that you've worked on?
Yes, that's what I've done in class.
Okay, you did that in class today?
Yeah.
Okay, so you saw this. A ratio is a part, and then you can use a division symbol to a whole. Okay, so can you tell me what the answer would be to the first one?
Third, 3 to 2 or 2 to 3.
Well, that's true, but it depends on which one we're doing. So the order matters here. So you're doing chairs to furniture, chairs to furniture. So how many chairs are there?
3.
Okay, and then the total number of furniture is 5. So you, instead of putting 5 though, you figure out what number gets you to 5, and that's why you put 2 here. So this is correct here. Okay, so you do need to know both, but you can just count the number of each and they go in that position. So like, look at number 2 here. What is the ratio of pumpkins to vegetables?
5 to 2 or 2 to 5.
Well, we've got to choose one. Okay, so they're not both right. So it's first pumpkins. How many pumpkins are there?
2.
2. And then it's not the whole, it's however many there are of the other type, which is 2 to 5. Okay, so the order matters. Like you have to put one before before the other. So, but you've already done this today? You've already submitted this?
Yeah.
Okay, let me pull up something new then. Now that I've got access to your class, I can navigate a little more quickly. Let's go back. Do you enjoy math, or do you have another favorite subject?
Career explorations.
Say that again.
Career explorations. It should show like it says like social studies, math.
Yes, yes. I was just asking what your favorite class is.
In like general or
Yes.
just in strong mind?
In general, what's your favorite class?
Science.
Science. Awesome. I'm just trying to pull up here. Now you're doing some stuff in IXL also?
Yes, which I absolutely
You
despise.
don't like IXL. What is it about IXL that you do not like?
It's very, very hard.
Okay. Do you have an IXL login?
Yes.
Okay. Do you have any way to share that with me, like in the chat? Do you know your username and password, or do you just access it through the class? Let's see if maybe you do it through here. Planet Math. Is it Planet Math?
Let's see. Where's your password? Right here. I know this.
How do you access like your week 9 IXL?
Or the password.
Okay. Do you happen to know what that is?
Yes.
He's typing it in right now.
Okay.
That's my password, and no, that's my username. I'm about to send you my password.
Thank you. Thank you. Is that you, Emma? I'm sorry, I didn't.
Yeah, sorry.
How are you doing?
Doing good. How are you?
Are you good? Are you in college now, or how's?
I'm finished math for the moment. I passed Algebra 2 with a B last
Great,
year.
great.
Yes. I will have to take a math class through the college, so we'll see what that's about. Maybe I might need your help.
Yeah,
So
we will see. Yeah, that's great. I'm glad you're there. So okay, let me share my screen here, Noah, and you can tell me kind of what you normally do when you work through this. So
The first one is username, and the second one is the password.
Yep, I've already got logged in here. Where do you normally go? Do you go to your math?
Yeah,
Go to okay, go to math. Okay, and then what do you do from here? Do you
the teacher normally gives us assignments on what to do. And you're right now on 8th grade.
Yeah. And so that is not you, or is that you?
he's in 6th grade.
6th grade. Well,
Although my teacher did make the entire class do 8th grade ratio.
okay, but it looks like you've already done week 9. Your week 9 weekly plan, is that, did you do the dilations?
Yeah, I think so.
Okay. All right. Trying to figure out what we could work on to best help you. What are the starred ones? What does that mean? They just,
What do you mean,
like here, division with exponents, is that something you still need to practice, or is it mean you've mastered
you
it?
just press. Oh, what does the star mean?
Yeah. Do you already know it? Is it?
I don't know what it means. I've never figured out, and the teacher never told us.
Okay.
And you're still in 9th grade.
But
oh no, you're in 8th grade this
yeah,
time.
yeah. See, we're in 8th grade. Okay. Well, let's go see what week 10 looks like. We'll just pull up angle criterion. Let's see if see what you've got here.
I have no idea what any of that means.
Well, we'll look at it together and we'll see if we can come up with something. All right, so there's two triangles that are shown. So a triangle uses three letters, L, M, and O, L, M, and N. So that's this one on the left. It goes, it's a direction. It's L or a path, L to M to N and then back. You can think of it as a giving instructions. So this other one is O to P to Q, O to P to Q. And whenever you have two triangles like this, you want to pair up the letters. So you might even write them like vertically over each other, like O goes with L, P goes with Q, P goes with M, and Q goes with M. And you can see that in the picture. Do you see that angle L is 57 and angle O is 57?
Yeah.
Okay, so what is the next letter in our list?
O.
Nope, it's got to go in order, L to M to N.
Okay. Then the next letter would be M.
M, yeah. And what's the angle measure of M?
61.
61. And M matches up with letter P, so this is also 61 degrees. So the letters tell you that the angles match. So then you move from M to N. And what is the angle? What is angle N? Well, we don't know it, but it's the same as Q. What's the measure of angle Q?
62.
So this is 62 degrees. Now, do you remember what the sum of the interior angles add up to?
No.
So in a triangle, they add up to 180. So could you add up these three numbers in the triangle and tell me if they add up to 180?
Okay. $180.
Yes, so they add up to 180. 57 plus 61 plus 62 equals 180. Okay. Now I'm gonna grab this picture one more time, and we're gonna talk about a new term. We're talk about similarity. Okay, so this is a definition. So two triangles, they're similar if all the angles are congruent. Do you know what the word congruent means?
Say that again. My sister was speaking.
No problem. So similarity, we're gonna talk about the phrase similarity or the term similarity. And by definition, this is just a definition. Two triangles are similar if all the angles are congruent. Do you know what the word congruent means?
No.
So congruent means that they're the same.
Okay.
So you just did this for me. Are the angles the same in the triangle?
Yes.
Yes. So are they congruent?
Yes.
So they are similar. So the angles are the same, which means they're congruent, which means that the triangles are similar. Okay, so let's look at another problem here. Okay, so let's look at the triangle on the left. The triangle on the left is PQT, P to Q to T. Okay, now I want you to find this missing angle T right over here. And to do that, you have to remember that the three angles in a triangle, what do they add up to? What is their sum in a triangle?
Either 180 or 231.
Well, no, it's 180, 180. So the 180 is the sum of the three angles, 52 plus 91 plus the missing angle. Okay, so can you add those up for me? Can you add up 52 and 91?
52 and 91.
Yes.
Okay, let's see. $143.
143, very good. And then I want you to subtract 143 from 180.
From 52 or
no,
36.
from 180. 180 minus 143.
Okay. Negative 36.
Try again. Try again. So 180 and you're subtracting 143. You're going to borrow from the zero. Zero isn't enough to subtract 3, so you're going to borrow from the 8. So that goes to 7. And the 1 comes above the 0. So 10 minus 3, what is that?
10 minus 3 is 7.
Good. What is 7 minus 4?
3.
Good. And then 1 minus 1?
1 minus 1 is 0.
0. So this angle right over here is 37 degrees. Okay. Is
Mhm.
that the same as this angle right here? Are these the same?
Yes.
They are? They're the same number?
Oh, no, they're not.
So they're the same if the angle measure is the same. But are they the same?
No.
No, they're not. Okay, now let's look at this triangle on the right. What do the 3 angles in a triangle have to add up to?
On the right, you said?
Yes. But in general, what do the 3 angles in a triangle have to always add up to?
180.
180. So here's your new equation to solve. I'll write it down here. 36 plus 52 plus s equals 180. Okay, we're trying to find this angle down here, angle s. Okay, so I want you to add up 36 and 52 for me, please.
36 plus 52.
Yes.
88.
All right, it is 88. Now we're going to subtract 88 from both sides of the equation. Now, if you haven't seen that before, that's okay. What I want you, what I want you to do is 180 subtract 88. I want you to try working that out on your own on the paper there.
I think it's 92.
It is 92. Good. Okay. So now when we go back and put that angle, do you see that these two are also not the same?
Yeah.
So for them to be similar, all the angles have to be the same. But they're not. So these are not similar.
Okay.
All right, let's go. Let me go back and see what else we can look at together. Just try to get some feel for what you're evaluating exponents. Okay. So this is just something totally different. I'm throwing up here just to see where you're at. Could you try reading this out loud for me in terms of like the math? How would you say this if you're in a math classroom?
7.2.
Okay, so this is actually 7 to the power of 2. Powers are actually exponents. So let's see here. That's probably not a good thing for us to work on. Let's see here, ratio. Okay, let me show you what this is. So 7 squared means 7 times 7. Can you tell me what 7 times 7 is?
7 times 7?
Yes.
49.
49. So what this means is, and let me give you another one. Let's say it's 4 to the power of 5. This means you write the number 4 5 times.
4, 8, 12.
But you're multiplying, you're not adding. You don't have to come up with this result, but I want you to see that when it's a base to an exponent, the base goes down as many times as the exponent tells you. Okay, so this isn't clear. It's okay. Let me try something else here. Trying to figure out what the starred ones mean to kind of help here with this. All right. I'm just pulling up some other problems here. Just give me a moment here to get this pulled up. Okay, so let's just look at something different here. Okay, so you've got two trapezoids in this picture. You've probably seen trapezoids before. They have one set of parallel sides. Okay, you can see that this vertical lines are parallel. Now the question is like, what's happening to go from the orange to the purple? So the orange is smaller, the purple is larger, and it's like, well, what's happening? What are you doing to get from one to the other? And maybe you can tell me that. So one of the things I think is important to do is to write the ordered pair. So let's have you, can you tell me this ordered pair here at M prime? Can you tell me the numbers to get there? How many right and how many up you go?
K, N, M, L.
Nope, no. If you're starting at the origin, how many right do you go? And then how many up do you go?
1 right and 1 up.
So 1 right and 1 up gets me to there, where I've just put that black dot. I want to get to where M prime is. Okay, that's okay. So let me go ahead and write the ordered pair for M prime, and I'm going to write the ordered pair for M. What do you multiply 3 by to get to 9?
Okay, multiply 3 by 9.
No, what number? What number gets you from 3 to 9?
3 to 9.
Like, what is 3 times 1?
3 times 1 is 3.
How about 3 times 2?
3 times 2 is 6.
And how about 3 times 3?
3 times 3, hold on. And this one. 9.
9. Very good. So notice that you take this 3 and you multiply it by 3 to get to 9. And you actually do the same thing here for this one. All right. Okay, Noah, so just you got a feel for what the lessons will be like. We'll try to just pick one topic to do with your brother. We'll just pick like one topic and work on it, like whether it's triangles or proportions or whatever you're working on. And we'll try to just stick to one thing. I was just trying to get a feel for your math skills and abilities today with some different problems. So thanks for giving me the chance to help you today. And I'll give your dad some feedback, but I hope we get to keep working together, and look forward to helping you next time.
Okay, bye.
Emma, thanks so much for moderating. Appreciate it. Have a good night.
You too. Okay.
That's it.
Bye.